I know that some of you were, a few of you were stuck on what was it? On the table not found, the admin user old table not found. Um, and for those, I think 4 or 5 of you were stuck on that. And for those, for you all, I think you'd all get an award for stumping not only me, but also Beej and Aaron Gallant, who is the resident Lambda School Django expert. So you've stumped all three of us. So that's me, the head of the CS department, and the head of the data science department. So I think you all deserve, those of you who had that bug deserve a medal for that. In any case, I think you should still be able to get through the assignments. You can, it's a little bit trickier to be adding users and adding notes via the shell, the Python shell. But actually, I think it's I would get used to that. Like I personally prefer to add things through the Python shell than through the admin interface. It's more powerful. You can do multiple things at once, and you can do things like run for loops and such. So you can do I think it's more powerful. But anyway, it's unfortunate that these things happen. But yeah, we weren't able to solve it, so I think you can just move on. As I mentioned yesterday, Python is very powerful, and it does a lot of things for you by magic, which has its good sides and it has its downsides. And hopefully, you've seen some of the good sides in that you're able to get this project up and running incredibly quickly. But now you also may have seen the downsides in that when there's bugs or when there's things that don't work like they're supposed to, sometimes they can be hard to track down. Sometimes things just happen mysteriously, and because they happen by magic, it's hard to figure out exactly what's going on. Heroku deployment of statics was a bit of a pain. Yeah, I think that there's is that in troubleshooting? I think it might be maybe it's in the Lambda mode troubleshooting. Anyway, yeah, static files can be tricky. For those of you who are curious, static files are things like JavaScript and CSS, which when you're deploying an API server, you don't need JavaScript or CSS or HTML, since all you're doing is serving API endpoints. But since you're using the admin console does use CSS and JavaScript and HTML. So the CSS and JavaScript are what's called static files, since they're loaded as assets. They're stored similar to how an image is. Also, if you have like an image like JPEGs or PNGs or GIFs or audio files, those are all static files. And they have to be served. They go in their own directory, and sometimes Django has some issues with uploading them. At a certain point, when your project gets bigger, you may want to even start serving your static files via something like AWS, where they can be loaded through the AWS CDN. But if it's small, you can bundle it in with your project. That usually applies more if you have like images, or maybe if you're serving video files or lots of audio or something like that. I think Heroku repositories have a maximum size of 300 megabytes. So if you're even nearing that, then you probably want to start moving your assets over to something like AWS. Bower stuff. I don't know that I've run into that, but it seems like you're able to get it up and running, Tom. So good job. All right, 18 people voted. How is that? That's only we have 36 people in here, so that's only half of the people. those who haven't voted, throw your votes in. I want to get a sense of how people are doing. There we go. 25 people. I think some people are still a little shy. Those of you who are stuck, again, those of you who got stuck on the old table thing in the admin console, I would just move on from that. Hopefully you did. Hopefully you didn't sit stuck and not making any progress because of the admin, and you're able to get through. All right, so let's see. So I said if we were able to get everyone through day 4 MVP, or at least 80% of people through day 4 MVP, that we would start. That would let you start on the Lambda, start looking at the Lambda Mud project, and we would start talking about it tomorrow. And it seems like we're on pace. So so a lot of people are on day 2, or have finished day 2. So if you can get through day 3 and day 4, and these are actually pretty short. So I'm going to go through those today, and it seems like we should be able to get to tomorrow. So before we do that, let me talk a little bit about what my plan is. So assuming people are able to get through, I'm planning to spend today talking about days 3 and 4, which are token auth and REST API. Tomorrow, I want to start talking about some things that you're going to be using in Lambda Mud, which are you're going to be extending token auth, you're going to be writing some new REST API commands, and you're going to be using a new library called Pusher, which involves WebSockets, which is a technology you may or may not have heard of. WebSockets are really cool because they allow two-way communication, whereas a REST API only allows one-way communication. So we'll save that for tomorrow. For today, if you're able to get through your through day 4 MVP, also as a special break, I'm making the executive decision that it's okay to start looking at the sprint challenge, which as Tom has maybe seen already, involves deploying to Heroku. Now the reason for that is usually sprint challenges you're only allowed to have 3 hours for them, but when it comes to something like writing an algorithm, like it is useful to be able to do it in a under time pressure. Since if you're in a whiteboard interview or things like that, you will often have time pressure for your coding challenges. However, things like Heroku, like deploying to Heroku, they can just take a lot of time for random reasons, like environment stuff or whatnot. So it's not necessarily a useful skill to be able to deploy in 3 hours, which is why if you're able to get through day 4 MVP, I'm saying it's okay to start taking a look at the sprint challenge early, if only so that we can get a head start on some Lambda Mud stuff. I really want everyone to be able to hit the ground running and to not be blocked by any of the Lambda Mud stuff. So so when we get to next week, we're going to go over the server tomorrow, and then next week you're going to be tackling the meat of the project, which is to build a front end for your Lambda Mud server. But that means we have a lot to go through today. Are there any questions about any of that? I guess I will say, if you do choose to go through the sprint challenge early, try to go through it on your own. And then if you're stuck and you have questions, maybe ask your PMs or things like that. And I don't know. So what point can you look at the sprint challenge? After day 4 MVP? Yeah, definitely get through day 4 MVP. Get through day 4. Maybe look at some of the stretches. I think you can start to deploy, and then if you're able to get deployment up, you can go back and look at some of the other stretches. Let's see, what do we have? So additional deliverables. All right, so don't forget to do this. Don't forget to do this. Michelle reminded me that this is part of the day. This is part of the MVP. But you can look at stuff like this. Brainstorm some new features. Add some ability to change records. Uploading attachments. I think this is tricky. I think this will require linking up with AWS, which is a pretty big topic actually. Filters and search capabilities could be interesting. That'll require you to look into the Django, some Django commands. Oh, you're right. Thank you. Let me share. All right, I'm looking at this. So make sure, yeah. So as I was saying before I was sharing, make sure that you don't forget about these deliverables. So you're gonna want to add another app. Remember, an app is separate from a project, right? In Django, the project is like DJ org, and an app is notes. So apps are meant to be pluggable. So you can plug it into this app. You can also take that entire directory and put it in another project, and it should plug right in. You can run your migrations, and it should work just fine. So you're going to want to create another app with some sort of data. It can be anything you choose. It could be pretty simple. It could be similar to Notes, but just give it a different name. Maybe some different data types. And then yeah, take a look at these. But yeah, feel free if you've blown through all of the previous things, you can take a look at the sprint challenge, which is sprint challenge intro. Okay, let me. I think it has a weird name. Django. Sprint challenge intro Django. Okay, so it's going to be this one. Sprint challenge intro. Sprint challenge just Django 1. There's a lot of instructions, but a lot of these are placeholder. Take a look through. There's a lot of mini steps that you may need to follow, and there's a lot of hangups that you might run into. But if you're able to get through to day 4 MVP, then feel free to take a look at that. Any questions about that? All right. Where do we leave off? I think, do we stop in day 2? So we did create super user, right? Did we look at the admin yet? I guess I could just look at the code, the status. Where do we leave off? I did create super user, I think. So let's see. Global hosts 8,000. I need to run my server. Manage run server. I need to pip m shell. Get my shell first. Now manage run server. Let's try this again. Go to our admin. Admin password 123. I think was password 123. Okay, maybe I didn't. All right. Oh, I guess I'll have to create super user again. Shell. All right. So maybe we didn't start this. Run server, admin accounts. So I'm going to create an admin account here. Admin, no email, password 123, password 123. It's going to complain. So I'm going to bypass it. We created a super user. Super user is is just another name for admin user. It comes from Unix, where the administrative users are called super users. If you've ever done sudo, sudo, that's short for do as a super user. All right, so that works. We're in here. We can see our users. Here's my admin user. Here's some notes. I have no notes. Groups, we don't have any groups yet. This is nice because we can add a note, new notes, some content, and we can save. And we can see our note here. We can also edit with edits. Yes, only super users can add notes. This is admin, so you should not be able to log into admin with a regular user. You also cannot create super users if you, so we're gonna add some, do we add some registration in day 3? I forget. But usually if you're gonna register, you can only register normal users. You don't wanna let people register super users. However, you can, if you look in your database, in like the Django shell, it's just gonna be a flag, which we can see if we do, let's see, manage shell. Let's see, let's import our user. User.objects.first should give us this admin user. We can do dir, just like regular in Python. And we have all of these things, and there should be just one that says like admin. You don't see it though. State, check password. Is super user. A.is super user. So A.is super user equals true. We can set A.is super user equals false, and then A.save. Oops, A.save. And now we should not be able to log into our admin console anymore. So let's log in again. Admin password 123. Okay, you don't have permission to. Oh, I guess you don't have permission to view or anything. So now we're not a super user. Now we can't do anything. If we set A as super user back to true, A.save. Now we can add stuff. I think, okay, that should be in. I guess it doesn't show here, but you can set permissions for what different people can do. Okay, in notes.admin.py, we did this, register personal notes. We have not created personal note yet. We can add some files to our model. Oh, I guess I did add personal note somewhere. Make migrations. And so we're adding the field created at with auto add now equals true, and we want to set this default now. This is for all of the old records. So let's do 1 and time zone dot now, which will set this to the default. Now we want to set this into our note.admin. And I think that should be it. Now we should be able to see created at in our notes. No such column, notes, note.created at. Maybe we have to restart our server. Oh, whoops, I need to migrate. Manage, migrate. Now let's restart. All right. server. Now our notes as, why can't I see it? Read only. Whoa, something happened. History. Okay, here we go. This is the history for created at and last modified. You should be able to see this somewhere. Is there a fan? I don't have a fan on. Is there anyone else hearing a fan? I don't have a fan running in this room. Is this better? Okay, that's weird. I wonder what it is. Let me unplug my mic. Is it still going? Okay, when I mute my microphone, does it turn off? So I'm going to mute it right now. And then back on. So is muting the microphone stop it, or is it still going? No, it doesn't. Then that means it's not my microphone. Wonder what it is. Is anyone in the channel unmuted? Let me see. Mute all. Okay, now everyone is muted except for me. Did that change anything? Okay. I mute myself. Did that just change it? Is it gone? Or not? Is it back? Okay. Okay. I don't know. Don't know. If I do that, then our recording is going to get interrupted, which is then we'll have to stitch it together. Let me see. Is there anything I can do here? Oh wait, how about this? Is this better? Okay, cool. What was it? It was oh, I think I was using the wrong microphone. I was using my laptop microphone instead of the external microphone. Yeah, I was messing with trying to get my audio working again this morning, and maybe I changed some settings. So I apologize for that, but it seems like we're good now. Oh, no worries. Thank you. Thanks for telling me. Thank you definitely for letting me know. All right, back to our notes. So we should be able to see the date and the time, but for some reason I don't see it. Is it in history? Is this what we're looking at? No, history does not affect it. Okay, now I'm kind of confused because I thought we should be able to see the date and the time from adding this this field here. Did I put it in wrong? Oh, here. Notes, admin. Ah, there we go. Voila. So we need to add this also. We need to register this to our into our admin site, and then we get this nice created at and last modified field. Notice that the time zone is not like right now. It's 12:38 p.m., but this is probably GMT. I think this is GMT, which is the default. And time zones, if you ever work with databases, are always a huge pain. So so that's something that maybe you'll run into later. But for now, we're able to see our date and time. So it seems like it's running as expected. All right, so now we talked about inheritance back in week 1. And Python inheritance works very much the same as Django inheritance. Or I guess I should say Django inheritance works very much the same as Python inheritance. So just like in Python, you put the class, you put the new class name, and then you put the class that it's inheriting from. And this inherits all of the properties from its parent class. And actually, this will create a note. So one difference here is that when you inherit from a note, this actually creates 2 tables. One will be the notes itself, and then one will be a new table called personal note that has a pointer to that note. So it has a reference, what's called a foreign key, that points to this note, and then it has its own identification. So let's see what that looks like. So we have our personal notes on delete models equals cascade. I think I already migrated this. So we can run db shell. I'll make this a little bit smaller so I don't have to keep scrolling. All right, so .manage.py db shell .tables, and please stop me if you have any questions. Otherwise, I'm going to keep going. db shell. So we have, these are all of our tables. So notice that we have a separate table for notes and personal notes. The way these tables are named is first is the app, then this is the model name, or the tape, I guess, the class name, and we can see what goes in each one. So we can do pragma table info notes.note. We can make this look a little bit nicer using these utility methods. Now let's call this again. All right, so this is our notes table. So we have a title. The type is varchar, which is a text block, and we have, so this is basically, this is a string. This is going to be like one like a line of text, and then you have text, which is also text, but text is usually is going to be bigger. So you usually don't have character limits for this, whereas you do have character limits for varchars. I don't know how to pronounce that actually. Varchar, varchar. I think I just call it varchar. I think it stands for variable length characters. We have our ID, which is going to be a 32 length character using the UUID, and then we have our created at and last modified columns. We also have these values for not null, default values. None of these have default values, and PK stands for primary key. So we assigned over here, we assigned our ID to be primary keys. So how much exposure have you all had to relational databases? fully 0. Okay. Andrew, you're iOS, right? How about web? How about full stack web? You had a SQL module. How SQLite via Connects? Did you talk about relational databases? Like what is it? What is a relation? How do you okay? And did you talk about primary keys and foreign keys? All right. One to one to many, foreign keys. Yeah, I'll definitely go over all of it. For the iOS students, but also because I'm guessing that all of you will could also use some review. All right. So um, so we have a relational database. What does that mean? We have let's look at this. Let's look at this notes. This personal note. Okay, so we have this personal notes. A personal note is the same as a regular note, except it has a user. So it belongs to a user. That means that's the difference between this is just a note owned by nobody and a personal note which requires a specific user. This is what's called a relation. So a relational database is a database where you have these different tables, and then the tables can link to each other. And as Adrian mentioned, there's a couple of different ways that they can relate. There's one-to-one, which is one table, like one use. If like let's say what's a good example? Let's say you have like house. Like let's say you have users and then you have house. Like every user can only have one house, or maybe it should be like home. Maybe you can have multiple houses, but you only have one home, right? So that's a one-to-one relationship. So a user will only ever have one home, and a home will only ever have one user. Okay, you can have a one-to-many relationship, as in the case of this personal note. So you have one user, that's the one, but one user can have many, many, many notes. Like you can cover your entire wall with Post-its. A user can have many notes. Oh yeah, this is default value. So right now these all default to null. Yes, employee has one employer, but employer can have many employees. So that's a one-to-many. So David, you described you actually described a one to, let me think. I guess that's a one. I still think it's a one to many. So this entire relationship, um, because like this personal note can only have one note. Wait, sorry. This personal note can only have one user, but a user can have many personal notes. So that's a one to many relationship. A one to maybe you can have like spouse, right? Like one person, you can only have one spouse, and then that person will also only have one spouse. Now there's a couple of different ways to represent this, but and this is the key. It's a little bit counterintuitive how it's referenced. So when you think of it from like a human standpoint, right? Like me, I have many notes. Okay, so I have 10 notes. So you would think, how would you represent that in a database? You would think, well, what if I created an array and I had a list of every single note that belongs to me, right? Well, it turns out that's not a very good way to represent it, for a number of reasons. For one, it would, like, say you wanted to see a specific note. If it belongs to me, then you would have to look up the user you would have to look at this list of notes, and you would have to go one by one to see if that note exists. 2, say you want to add or delete. You're going to have to do all of these array functions. And remember, it's hard when you're adding or deleting from an array. That's a big O of n operation. All of these are bad. So the way that we actually represent it is that we, in a one-to-many relationship, you represent it in the many. So we put, so we would, instead of saying like in the user array, having a list of all of my notes, each note will have who they belong to, right? So here you can see this note has a user ID. So we can, so if I create like note 1, note 2, note 3, note 4, all of these will have belongs to user, we just say Brady. So these all belong to me. This is better than saying Brady owns notes 1, 2, 3, 4, right? We don't want to do this. Also, another reason we can't do that is that arrays are not a supported data type in most databases. I mean, some databases allow you to use JSON, but it's not very efficient. So this is how you represent a one-to-many relationship. In each of these, you put a you say who it belongs to, and you can see that here. Each personal note has a user ID that belongs to here. We can if we created more personal notes, you would see that each of these will have the user ID pointing to me. Now, what's a common operation? You might say, show me all of my notes, right? That's a very common operation. Like if you're creating a notes app, you would have to say, show me all the notes I own. So with this one-to-many operation, how do we do that? Well, we just say, give me all of the personal notes where user ID equals 1. Can anyone tell me what the big O of that operation is? So give me all the personal notes that belong to me. Big O of n. Yes, you're correct. Sort of. So you're correct that it's big O of n in that you would have to go through each personal note, check each one to see if the user ID equals 1. Like let's say my ID is 1. You'll have to check each personal note and see if it's 1, and then you would return that. So when I said sort of, that actually never happens in practice, because whenever these you're storing IDs or primary keys, they're sorted, or what's called indexing. So you'll always index these columns. That means that since this is sorted, we can do a divide and conquer, and it ends up being a big O of log of n, which is the big O of finding something in a sorted list. That means every time we add a new note, we'll have to put it in sorted order, which is also a log n operation. But that's what relational databases are. If you have a one-to-one, it's this. You'll have this this foreign key. So this is an important term: foreign key versus primary key. Primary key is is your personal key. So that's what you're referred to as. So my user ID is 1, and my user ID is the primary key that other things will point to. A foreign key is something that points to another table. So in this personal note, user ID points to this is a personal note table, right? So user ID is a foreign key, and that's why we name it here. So in our personal note, we add a foreign key that points to this foreign table, which is the user table. If we look at the user table, let's see, what is our user table called? Auth user. If we look at our auth user, we can see that we have this ID, which is a primary key. You can only ever have one primary key for any table. So that's important to remember. That's why it's called primary. You could make primary key the username, but then you would need to make sure that this username is unique. But usually for like sorting purposes, you just use it as an integer, or you can use it as, in this case, in the case of our notes, we made it a UUID. Are there any questions about that? I'm sure there must be some questions. Doesn't the operation execute in the same time regardless of data set n? Which operation, David? The previous question, get all personal notes. It does not operate in the same time. If you have 10 million personal notes in your database, it's going to take longer to find your personal notes. It's good, David Lyman, to keep you sharp. If you're searching by ID, so if you're searching by ID, but you're not searching the notes by ID. So this personal note has two IDs. So it has its own ID and it has a user ID. So if you're searching by its own ID, like if you say, give me personal note 1. I'll keep going just because I think it's good to go over. You're searching for personal note 1, then that's easy. You can do that in constant time. But if you're searching for all of the notes that belong to user 1, then you're going to have to look through everything, each one, and check what its foreign key points to. And you need to get all the ones that point to this user. And since we have a one-to-many, you don't even know how many it is, right? Like out of that 10 million, maybe 500 belong to me, and they're added all at different times. So you're going to have to go through each one to figure out which ones belong to me. O of n, unless it's sorted, or as we say in database terms, unless it's indexed. Because it's not actually sorted in the way that you think of an array, where you put it in different orders, right? It's actually an index where you have your thing in order, or I mean, actually they're scattered all over your database, but you have an index that says the first one will be note 54, the second one is note 62, the next one is note 573, et cetera, et cetera, et cetera. I don't think that they're used. So indexes are implemented, at least in Postgres, they're using B trees, I think. B trees are a form of balanced binary search trees, which is why we can do the divide and conquer to get log of n to access. All right, Andrew. How do you make rows into columns for tables? So, okay, let me start with how do you make columns. So you make columns by adding columns to your model. So this is where you define your columns, right? So here you can see it matches up exactly. Here's our title, max length 200. We have our content. The type is a text field. We have our ID. It's a UUID 4, and 4 means 4 bytes, and each byte has 4 bits, which is where we get 32 from. We're also saying it as a primary key, which is why we get PK1. created at and last modified are each date time fields. So you create columns by adding to your model. Now how do you create rows? You create rows by you can do it through this Django admin, or you can do it through the shell. You can do it through, or if you create like a CRUD interface, you can do it through that. Or if you create an API interface, you can do it through that. This is similar. If you go back to week 1, how you define like your room class, right? First, you just define your room class and say every room has a name and has a description. Those are like your columns. You have a name column and a description column. And then you need to actually instantiate your objects, which is you create a new room and you create another with a room like, outside. You were at the entrance to the cave. So that's a room. That's a column. That's like a column in your database. Does that make sense, Andrew? That's a really, really important distinction. And like, what's the difference between a row and a column? How do you create a column? How do you create a row? Rows you can think of as records, as database records, or an entry in your database. They're kind of like instances or objects. Like if you think of the table as your class, the columns as the class attributes, and the rows as objects or instances of your class, then you can have a pretty good idea of how that translates to a database. The big O for retrieving all notes owned by Brady would become big O of 1. So why is it bad to do that? Well, to answer your question, it has to do with how these things are stored. For one, like I mentioned before, there's no array type in the database. So if you look up like SQLite types, SQLite data types supports null, integer, real, text, integer, real, none. Wait, what am I looking for? Okay, here we go. Okay, so it supports these types. It supports integers, texts, blob. I don't know what blob is. Real is like floating point numbers, and then numerics like date time. So you notice there's no arrays, right? You can't store it in an array. Databases are, like, for various reasons, they have to be really efficient. So arrays are problematic because when you create an array, you have to declare the initial size. So how, like, do you say like 10? You say you can have 10 notes, and then if you add one, then you're going to need to delete that array and then copy it over to another place. That's also a similar reason why you have to set the max length for your strings. And I mean, you can again, some databases like Postgres supports JSON, and then you can create an array in JSON, but it's not particularly efficient. And when we're talking about databases, these need to have absolutely the most efficient access. Because think about, again, if we have 5 million notes in our database, you need it to be super fast to access, super fast to read, and super fast to write. And you can do that. It's more efficient to do it with primary keys. And the other answer to this is retrieving all notes owned is not the only operation that you need. Like, you have creating notes, you have removing notes, you have editing a specific note. And if you want to edit a specific note and you need to see who owns it, I guess, like, for example, if you have a notes and you need to see who owns it, how would you figure that out? How would you solve that? If you're storing the notes in an array that belongs to the user, how would you see, if you have a note, how would you see who owns that note? You would have to go through every single user, check their arrays, and see if if your note ID belongs in there. It's also very error prone. Like what if, notes and users are a one-to-many relationship, right? But what if I have a note and then you also have a note, right? So then, um, this note, it says that I own it, and then Ty, maybe you also have that same thing. So now, who actually owns it, right? It's impossible to enforce the one-to-many relationship that way. However, if every note belongs to only one person, and it's possible that each note can have the same owner, then we have a very nice one-to-many relationship built in. Ty, I hope that answers your question. Okay. Oh, how to display in the terminal? That's a much easier question. And I'm glad you asked, because that's the next thing that we're going to list. So select star from notes note. So star is a wildcard. That means select everything. So you can to look at everything in the notes, you run this SQL command. So this is raw SQL. SQL stands for Structured Query Language, and most ORMs, which is like Connects is an ORM, or the Django shell is an ORM. Most will abstract this away. But when you call something like, let's see, let's run pipenv shell manage shell. So when we do something like user.objects.all, oops, this is actually calling SQL underneath the hood. This is basically calling this selects, oh, I guess not notes. This is selects are from admin user. User admin? Auth user. And we can see all of our users here. It's a little ugly because of our primary keys. But you can see the columns here. If we added more notes, we can add another note. Let's see if it shows up. Add notes, new notes, some content. Let's save this. Now we have two notes, and we should show that new note show up here. Okay, so now we have our new note. New note, some contents. Does a database ever allow a many-to-many relationship? Yes, it does allow many-to-many relationships. Those are a little more tricky, and they're also more rare. You can see database many-to-many. So these require what's called junction tables or join tables. This is something like if you have friends, like a user can have many friends, right? And each other user can also have many friends. So that's a many-to-many relationship. And the way you declare that is by creating a friendship object, or like another table called a friendship table. Like that's how Facebook works. And you also need to create two different friendships. So when you're creating, like if you were creating a social network, you would have your users table, and then you would have the friendships table. And then for every friend, if user one is friends with user two, you would need to have a friendship user one to user two, and user two to user one. Which may sound familiar from your sprint challenge last Friday. So that's exactly how these junction tables work. You need to have an intermediary table that defines the many-to-many relationship. That's getting a little more complicated though. That's something, if you want to look more into, you can check it out. Yeah, so in this case, in the notes with many authors and editors, you would need to have something like an authorship table where you define like this author, this row, it would be something like author notes, and then it would be this author writes this notes, and this author writes this notes, um, which will join them together. Any more questions about about SQL? I guess, do we finish everything here? I guess we can create a personal note. We also want migrate. I think we migrated this already. Personal notes. Okay, we already looked at this. The foreign key ID. We have this auth user table. Oh yeah, and then we can look in our other shell and see the same thing. So we can import our personal note. We can see this personal note. Oh, we didn't create a personal note yet. Do we add personal note to our admin console? I don't think we did. Admin. Is there some code I can copy paste there? Personal notes. Okay, I guess we didn't. We can create a new one like this. PN equals personal notes. What does a personal note have? Personal note needs a title. Title equals personal notes. Content equals personal content. And then this is going to throw an error when we try to save, because we don't have an ID. So a personal note has a requirement that we need to give it a user ID. So we can do that with by just adding a user. So let's add our user here. So user equals user.objects.first, which should give us our admin. So here our user is admin. Now we can say pn equals personal notes, content, personal content, and we can say user equals you. That's going to be our admin user. Now we should be able to save. Now we have a personal note. We should be able to look at this here. Personal notes. Personal notes with an L. And we have, okay, you see we created a personal note and we have this table. But what does this mean? We have user ID 1 and then we have all this garbage. But if we look at our notes table, you'll see that this garbage matches this garbage, right? So this is the primary key. This is the notes primary key. Here is our personal notes foreign key. This is also a foreign key. So it's pointing to user ID 1. That's our admin. And then it's pointing to the note ID, which is this one. So you can see our personal N, personal note here, our personal contents, and it's referenced by this ID. Make sense? What keyboard command am I using to traverse text to find a word? Which one? When did I do that? I'm looking for something, I search for a word, and it highlights. Oh, it's just Command F, find personal notes.
Personal notes becomes the notes title also. Yes, yes, because it inherits. Personal note inherits from notes, so it has everything that belongs to a note, but it also has this user ID column. So unlike your Python objects where it's creating an entirely new personal note with all of these things in it, this is just creating a table that has only the unique part, and then it points via a foreign key to its parent model. So it'll create something in the notes, and it'll just point to it. If you override something, like if you override title and say maybe a personal note can have a title of length 300, then it will create the new column in the personal note as well, in this personal note table. All right, let's take a 5-minute break, and then we will keep moving on with some API. Timer. See you in 5. All right, and we're back. Sai, I think I realized I misunderstood your initial question. If you set your primary key of notes to title, the foreign key for personal notes becomes the note title also. Yes, I think so. I think so, but that might be some Django magic. I don't know for sure without trying it. And if I were you, I would just give it a try and see if it works. That's the best way to figure this stuff out. All right, so we talked about a little bit uh, about relational databases. Now, obviously, we haven't covered all of it. Database architecture is a huge topic and something that we could go on and on and on about. But if you keep in mind these things like what relations are in a relational database, you should be okay. Briefly, we can talk about what a non-relational database is, or a NoSQL database. Something like MongoDB is a non-relational database. MongoDB is a NoSQL. So NoSQL is uses what's called document storage, and this is sort of what we were talking about with arrays. So document-based storage is how NoSQL stuff works, and this basically says for every record you just have a bunch of data in sort of an arbitrary structure. This is simpler because you don't have to define all of your relationships up front. You can just say, all right, we have a user table and users have all of this stuff. And if you want to add stuff or remove stuff later, you can do so at will. It's a little bit more flexible since you don't have to define everything up front, but the performance is not as good. Sort of for the reasons that we described, where like if you want to see who does this note belong to, you may need to comb through a whole bunch of different data. But that's a topic for another time. All right, let's move on to REST. Setting up a RESTful API. REST stands for representation. Oh gosh, representative state transfer. I can't speak. REST framework. Representational state transfer. That's a really hard thing to say for some reason. Representational state transfer. There we go. Representational state transfer. All right. What does that mean? REST is basically it's a convention for doing CRUD, basically. It links up with like get with HTTP requests, like get and put, and it defines the things that you can do. Creating a RESTful API, it's a lot of API design is following standards. Like you want to make your get like if you want to get a list of all of the users, you want it to be something like get your URL / users. If you want to like get one user, you would do like get your URL / users / whatever the user ID is. If you want to create a new record, you would do a post. If you want to update a record, you could do a put. Things like that. And then there's also standard HTTP responses. So if a record is successfully created, you get a 201. If you have data not found, you get a 404, and so on and so forth. Internal server errors are 500. There's a huge list of all of these things. Now you want to follow these conventions as best you can, but you can actually do whatever you want. You shouldn't do whatever you want. You should try to follow conventions as closely as possible. But a lot of these are just conventions. and there can be a lot of setup to set it up, but Django will take care of a lot of this for you. They have this nice package that you can install called Django REST Framework that will do most of the heavy lifting for you. So let's get out of this. Close this. Where are we? We have our server running. All right. Pip m install Django REST Framework. So first we install our REST framework. We want to add our app to settings. REST framework. We want to add this permission classes. So this is very cool that we don't have to define all of this stuff ourselves. This is one of the huge upsides to Django, is that it takes care of all of these things pretty much out of the box. I think that's it. Okay, we wait for our thing to install. It's taking a while. Come on, Django. All right, well, let's keep moving while we wait for this to finish. All right, we're going to create a new file called API. Hit them, shell. Why is it just hanging? Okay, we're going to create new notes, api.py. We're import our serializers. Done yet? Not yet. And then we want to add our personal note serializer. What a serializer is it's basically taking a database record, like basically a row or an object, you can think of it, and it's taking the data and serializing it in a way that can be returned through the API. What that means is, like, if you have a user, like a user has all of these different things, not all of them you care about, and it'll return like all of the things you do care about, which are maybe your name, maybe your email address, but you don't care about that that UID. So that's what serializers do. Oh, we did finish. I was just scrolled down. Okay, so we can put this inside of our serializer class. We want to include our view sets. Let's link this back to the serializer class that we made previously. Well, let's just copy all of this because I know that we're going to need to get there anyway. All right, let's talk through. So here we're creating a serializer for personal note. This means when we call the personal note via the API, this is what we get back. We get the title and the content, which is all we care about. And the view set will basically take our serializer class, and it'll return it in what's called a query set. Now these are Django conventions, but these allow you to also access the serialized data as a query set. I guess we can commit git status, git dot git commit m. What do we do? Added admin, personal notes, and serializer. Status, we're clean. All right, now we need to add our routes. Routes are how we access our APIs. You can also think of them as URLs, which is I save, git status, not save. Commit, added, this is serializer and view set. All right, so now we need to create our route so we can access our API. So we go to URLs. We import this. From REST framework, we're importing our routers, and then we import our view set, which is going to be used to serialize. We create a router. We register with our router our notes view set. From Django, we have this we can include. And then we're adding this API. Now we should be able to test it. So run the server, navigate to /, okay, we can look at that through here. Localhost 8000. Django comes with, am I running the server? I'm running the server. Okay, Django has this very cool API viewer. So we can see this get function. We can also look at notes. And you can see this pulled a note. Use the admin feature at the bottom to attempt to post a new note. So let's see what happens when we try to create a note. New note, some failed content, because this will fail, hopefully. And it fails again. For the similar reason that we saw when we tried to create a personal note in the shell, is that we need to assign it a user ID. So we will need to add that to our serializer. So in api.py, we look at, all right, this is broken code. Oh, this is very cool. This is really cool. I found myself using this a lot yesterday to try to debug some errors that students were running into. And I encourage you to do the same if you find yourself stuck. So you can run this really cool debugger, and now we can try to run this again. And we get this this prompt here. Now this is a Python shell, so we can do everything in Python that you can do in a regular Python shell. So you can do like x equals 5, x 2 gives us 25. Cool, it's regular Python. But we can also look at we can also see what these variables are. So we can see self. Self is this personal note view set. We can do directory of self and see what self has in it. And we can look at self.context request. What? Has no. Why does it have no attribute context? Self.context. Am I doing something wrong here? Oh, this is in personal note serializer, not view set. My mistake. My mistake. So let's exit out of this and let's run our thing again. Resend. No exception message. All right, let's just try to add another one. Post, here we are again. Self.context request gives us this request object, and we can look at it to see what the user is. All right, so here we can see we're storing the user. So we want to set this user. We want to assign this because this is the currently logged in user. We want to assign that to our personal node. So we can add this to our creates. Again, so self.context.request.user. We figured that out. We figured out here will give us this user admin. So we create our note using the validated data. This should look familiar for you Python from week 1. This is a keyword argument where we're passing in all of the, we're passing in a dictionary, and then we're setting this default arg to user. If you want, you can check the PDB of this as well, which is a super, super cool feature. Let's try it again. We can look at validated data. You can see it looks like a regular JSON, a regular dictionary that just holds our title and our contents. So that all looks good, and we should be able to continue. And no exception message supplied. Am I missing something? Do I need to save? Turn notes. I think I'll need to, let me just try this again. New note, some successful contents should be. Successful content, yeah, and it created. So we get an HTTP 201 response. 201 means that we have successfully created a new record. And we're, so it seems like it's working. Debug as needed, then commits. Right now, any user can see in all of the nodes that are in the database. Okay, so change query set to initialize with none.note.objects.none. This will create a variable with an empty dictionary of the correct type. To make a decision based on whether or not the user is anonymous and return only the nodes that belong to the logged in user, we can override this method called getQuerySetSelf. Load the user into a variable, and then that will be self.request.user. And we can add this to our personal note view set. Let's throw this in here. Personal note view set. Get query set is overriding the default query set, which is at this. Okay, I think this overwrites this. Yes. So I think now our note list will only return the notes that belong to this user, as long as we are logged in. So if we look at notes get, so here are all of the notes that belong to me. If I create a new user, let's see, create super user, manage create super user. Let's call it new admin, password 123, password 123. Let's override it. Let's log in as that user. Log out. Let's log in. New admin, password 123. Log in. Don't save. API notes. All right, and you can see now we have nothing. Now there's nothing here. So that seems all look good. All right, the last thing we have to do is set up CORS. CORS is cross-origin. I forgot. Cross-origin request something. CORS. What does CORS stand for? Cross-origin resource sharing. What this handles is sometimes you want to make sure that no one is only certain protected people are accessing your API. So you want it so you have like an allowed list, whitelisted list of sources that can access your API. But since we can also just allow everybody to do it if we're since we're all open and friendly with our notes. So that's REST. That's this RESTful API. We can so when we looked at our API thing, we can actually probably hit this from here using like curl. So let me read me curl. I don't like to copy paste, so I'll just copy this. So we should be able to, we don't have any header. This is just going to be a get, I think. So API notes. And we should be able to do this. I guess it doesn't return anything. It returns a 200, I think because we need to have a user, which we will take care of, which we'll handle in day 4. So before we move on to day 4, are there any questions about day 3? It's been pretty quiet out there in Slackland. Crickets? Okay, good. I'm glad that the mic is still on. I kind of understand if there aren't that many questions. This is kind of a thing where you can just copy paste and read through the stuff, and I know you probably kind of understand it, but not really, and that's fine. You'll understand it a lot better as you build it out and if you start using it. And that's sort of what next week's project is going to be about. So you're going to be using like a REST framework. You're going to be using token auth. You're going to be using an API and accessing that API from an external front end. And you're going to be working with this stuff a lot. So it'll make a lot more sense. But the first step is you just kind of have to go through it. Did you do the React request with Axios? In order to do that, I would need to get a React app set up, which I don't have. And also our API isn't set up because we're not passing in a user yet, which we'll need to take care of with token auth. So we'll be able to do it next. We'll be able to do that next in the next section. But again, I don't have a React app set up, so I will not be able to do it through Axios. But I can do it through curl, and curl is pretty much the same as Axios. So we'll. I like that slow motion party parrot, Lucas. So let's just move on, and then we'll talk about token auth. Because token auth is actually something that a lot of people use without knowing how it works, and this is actually something that you should absolutely know how it works. I know this because I asked people about it in their capstone defenses, and they say, "Oh, I implemented JWT, JSON Web Tokens, using token auth," and I asked, "Oh, how does it work?" And they have no idea. So I'm going to make sure that you all know how token auth works, and then 2 months from now, 2.5 months from now, when you're in your capstone defenses, I'm going to ask you about it, and if you don't know the answer, then I'm going to be very upset. All right, so let's run through this. Token authentication. Open up settings.py. We already have it open. Installed apps, add REST framework token. So we have our REST framework installed already. REST framework.auth token. We need to throw in these default authentication classes. This is all boilerplate. So, this doesn't go in here. This goes in here. This is all boilerplate stuff. So, let's see. Default authentication classes. These are the things that it's loading. Set up the route. So URLs. We'll import repath for REST path, I believe. Repath, REST framework auth token, import views. Are we importing that yet? No. Let's throw that in there. Then add the endpoint in URLs by adding the API token auth route to URL patterns. So let's throw this in our URL patterns. Okay, this is raw. This R here is raw, and what that does is it means that not raw. This is a regular expression. Is that what an R string is? Is it a regex? Or is it raw? I forget. Yeah, it looks like a regex. So it's saying that the caret is matching the beginning of the string. So it's saying that this is going to be the start. Oh, I guess repath is regular expression path, not rest path. So I guess it's solving for this using by treating it like a regular expression. Regular expressions are a topic that we no longer go over, but they're very cool. It's basically a way of finding string patterns and matching them. But let's do a migration. Manage, make migrations. Migrate. And we're adding our auth tokens into our database. Now we can test our endpoints. So the following makes a post request with the given JSON payload. So let's run this guy. All right, so what are we doing here? Curl X. So X is the type of request we're making. We're making a post request. H is for header. Header is saying that this is the content type JSON. And D is our data payload. So we're sending in this data, username admin, and password is capital password. And this is the URL for our endpoint. So if we run this guy, okay, unable to, oh, because I already created a, what am I doing? Am I logging in? I think, okay, so this is not my password. My password is password123. Password123. All right, and you see we got this token back. Everyone get that? Here, I'll do it again. I'll do it again in a clean window. So I'm passing in this post request, which is sending in the username and the password. This is my password, and I'm sending it to this token auth endpoints, which I just defined right here. I hit enter, and I get this back. So I get, what is this? What is this? This long crazy thing is your authentication token. Now what this is when you have your server and you have your client. The server is this backend, this API Django backend that we're creating, and the client is the front end. That can be your iPhone if you're building an iOS front end. This can be your React app, your Android device. It can be whatever you're accessing this from. In this case, it's just my computer is the client. So what this is this is a placeholder for your password. You can store this locally. So once you do your login and your authentication, you store this locally, and now you no longer need to use a password. Instead, you pass in this token as your means to authenticate yourself. This means that you can keep accessing tokens, and by owning this, you can guarantee that this person has been authenticated. And you don't need to store the password locally, right? Like you don't want to have password 123 stored on your local storage. Instead, you store this token. Now, one thing to keep in mind is that this token is basically a key. So, I'm talking like a door key that you can put in and unlock any door. So if someone steals your token, if someone can hack into your phone, do a dump of your local storage, and get a hold of your token, they can actually access all of the data. They can access an API just as if they were you. So even if they don't know your password, they can still access this stuff. So tokens, there are some security risks to using authentication tokens. But it's much, much better than storing your password. In production, there's a lot of security things that go along with tokens. Like you have expirations, like your tokens will expire. Sometimes every time you send an API call, it will regenerate the token and it'll send you the new one. So tokens are like one-time use only, things like that. Often they're stored in cookies. So this is why, like when you log into Facebook, for example, and then you go away for a day and then you come back, you don't need to log in again because you already have your token. And this works across any device, across any front end. Something that I see a lot of students confused by is that they say, I'm logging into the server, so I'm logged in on the server. All right, that is not true. The server has no idea if you're logged in or not. Like there's no session stored on the server when you're doing token auth. There's no session that persists and expires. All it does is it hands you this token and it says, as long as you give me this token, I'm going to believe that you are who you say you are. Is that clear? Eventually, you want to add salts to the data and create a hash. So you add salts when you're hashing a password, but tokens are actually stored in clear text. So like we can take a look at this in our shell. What am I doing? Manage shell. We will import our users. Import user, user.objects. Which user am I looking at? Okay, our first user. So first, u equals this, dir u. I think it's just u.token. Is u.auth. Auth token. Hey, reading through, here we go, auth token. u.auth token. All right. If you see this token that we got returned, it matches this token exactly. 1AA82075E81D blah 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 blah. So this is stored in clear text. So if anyone hacks into your database, they can also grab your authentication token. Now your password, if you do u.password, you'll see that this is hashed. So this one has salts. This one gets hashed with salts, and this remember my password is password 123. So here, if you hack this database, you will not be able to find my password, which is good. That's nice and secure. But you will be able to get the auth token. So it is possible to that there are some security risks with this. Does that make sense? And this is also, and you can also see once you have this token, then you're not logged in, you just have the key. You need to do auth token. This is like logging in that you send your username and password and you get back a key. But once you have that key, you can do anything you want. unless your database is set to expire your keys at a certain time, in which case it may become invalidated after a certain time. Or if your key is regenerated. If you remember recently, speaking of Facebook, if you remember recently, Facebook had a security glitch where all of their keys were compromised. So they had to regenerate like 50 million or something authentication keys, which is why everyone was logged out, because they invalidated all of these keys, and which meant that your persistent sessions were no longer valid, and everyone had to log in again. Quora yesterday seems like there's been a reckoning on these database securities. But there's trade-offs. There's trade-offs with all these different kinds of with these different authentications. This happens to be pretty secure, but keep in mind that if someone steals your token, then they may as well they can have access to all of your data. Is the key strictly for backend? You check the username on the front end, but you need the key to access data from the database. You send the key. You send the username and the password. So the user types in their username, they type in their password, and then they send that with an API request. So if we look at this thing, this is the API request. So if you did an Axios call, Tom, are you web or are you iOS? Okay, so if you're web, you've done Axios. I don't know what it's called in iOS, but I believe that in iOS you've also consumed APIs. It probably has some different name. Okay, so if you do an Axios call, you send in. This is your URL. This is the exact same as this. It's your URL. You have your header. Your header will be. You'll send your token. Okay, this is a bad example. If you're to do an Axios call, it would be like axios.get HTTP. Here's your URL. Data would be this. I think data equals. I don't actually know off the top of my head, but I think it'll be something like this. You send in the username and the password as the data. You have your header will be like contents type JSON. Something like this. You have no concept called promises. You will have a return. So once you send your API request, you'll get a response, and based on that response, you'll do something with that response payload. I'm sure that's how it works. Yeah. So you'll get so you send in something like this. So basically your URL, this is also probably going to be a post get. So you're going to send in your URL, your data payload. This is just saying that you want it in JSON, that you're looking at the JSON format, and you'll get this response of a token. Password 123. And you get this response back. Based on this response, you store your token. If it's an error, you'll get something like bad password. So if we do like this, you'll get an error, unable to log in with provided credentials, which is as is expected. But otherwise, you get your key. Now, once you have your key, you can access it. So the way you do that is with, sorry if it's confusing that I'm adding this all to my models file. I probably shouldn't do that. That's, let me put in a different file. All right, so here this dash H is for header. And this is a very, very specific format that you have to put it in. So let's look at the Axios. So this is the key and this is the value. And the value needs to be token, one space, and then your key. So here, what was our key? Our key was this guy. So let's put this here. And let's try running this. Okay, and you see, we got all of our notes back. Title, personal note, content, personal contents, new note, contents, some failed content, title, new note, content, some successful content. So this is all the stuff we created back at the beginning of class or throughout the class. This is guaranteed to be unique. This token is guaranteed to be unique. So if we try to do the request, we can use our other what was it? Oh, new admin? Was that what we called it? Password 123. We should get a new token. Now, if we run this with the new token, okay, it's hard to see, but you can see we have this empty array back here because our new user, our new admin, does not have any, has not created any personal notes. So not only is this key will unlock everything, but this key is also now how we're used to identify it. Like you see, nowhere in this payload does it say user ID. Like we're not passing in a primary key. We're not passing in a username. We're not passing anything except for this token. But Django is smart enough to take this token and find the user based on this token. So this is serving the double duty of an identifier and also the authenticator, which is why it can be very dangerous if it gets out. You know, for things like bank software, this is why banks will log you out of your app when you haven't used it for a long time, because it will it makes sure that the keys do not have a very long lifetime, so it makes them harder to steal. Yeah, exactly. Username, password, and identifier all in one. Another thing to take note of is that the username types in their password and they send it, and it all goes in clear text. So it doesn't get hashed until it hits the back end. So here's another vulnerability. If someone intercepts it along the pipe and you're not encrypting it with HTTPS, then it's possible that they can read your password in clear text. That's why you want to make sure you do HTTPS. You see here, we're just doing HTTP. I mean, we're doing localhost, so it doesn't matter. But HTTP can be read in clear text as it goes through as it is sent down the pipe. HTTPS will do end-to-end encryption, which means that your password will be secure as it travels from your front end to your back end. What else? So there's a few different ways to do this. You can use PowerShell, you can use curl, you can use Postman. Windows users, I've through my experience working with other Lambda School students, curl does not tend to work very well with Windows. So a lot of Windows students use PowerShell. Curl is pretty nice on Mac, so I like to use curl. Axios is in React. In JavaScript, it's called Ajax. So I'm guessing this. I bet this AX stands for Ajax, or it comes from Ajax, but I'm not totally sure. But anyway, that's about it for token auth. It's not too complicated, but there's a lot of subtleties that you need to make sure you understand. How do hackers intercept a signal sent through HTTP? There's a lot of ways. There's a lot of ways to do it. As you as we talked about a little bit in Graphs Week, the internet is a series of different nodes. You could actually literally take a wire, like chop it, stick like a thing in between it, and read it from there. One of my first jobs was working for the government, which is where I got my security clearance. That's good for another few weeks. I got it actually almost exactly 10 years ago. And one of the projects I worked on was end-to-end encryption for utilities. So there's so like now you have like the things that monitor like your power plant, your hydroelectric plant, things like that, and they're all monitored remotely. And you need to encrypt it end to end, otherwise people can literally like just get in the middle, send malicious signals, and overload a transformer, and then boom, it's $1 million, millions of dollars of damage. So you can do that. You can, if you get to one of the nodes, you can start reading the traffic. You can just see what the traffic going in and out is, and if it's unencrypted, you can see it through there. There used to be I forget how it works, but if you're logged into like a public Wi-Fi, like you're at Starbucks or something, and you're using an unsecured wireless network, people could grab your sessions and see the traffic that you're passing in and out. There was some like Firefox plugin that let you basically steal like someone's Facebook session, and then you can use that to log into their Facebook. There's a million different ways that people can hack stuff, and to be honest, I'm not an expert on that, but I'm sure that's something you can read up on further. But basically, if you're doing anything with usernames, with passwords, you're gonna want to do HTTPS, because that's so TLS it used to be SSL, but I think now TLS is the preferred method of encryption, which handles all the security stuff. And that's something you can read up further on. I can't tell you off the top of my head how TLS works or how SSL works, but it does handle end-to-end encryption for all of your data payloads. All right, so it's pretty good timing. What do you think about all of this? Any questions? Anything from day 1, 2, 3, or 4? Recommended is SSL login. So username. So if you're doing SSL login or TLS, I think isn't it still just username and password sent through like an end-to-end encrypted pipe, David? Maybe I'm misunderstanding. Are you talking about SSO? Are you? I think I think you mean SSO or like OAuth, right? Is that where you use like your Google accounts to log into GitHub, or your Facebook accounts, or your Twitter accounts? That's interesting. You create a new project. like if I create a new GitHub, so I'm on Git, like create a new repository. So I created a new repo. It's a public, private, license. Git ignore, it's not it. Okay, we'll make a test CS13 repo. SSH. Okay, SSH. SSH is how does SSH work? Oh, like this to clone. Yeah, secure shell is I've never done it like this, but this is actually like creating a tunnel to like a remote server as opposed to doing it over HTTPS. So I think they're both probably equally secure. I guess I don't know the difference in security between SSH and HTTPS. No, that's a good topic. It's we are on topic. This is what we're talking about. No, no worries, no worries. I'm glad that some people are talking to me, and I'm not just alone with the crickets. But anyway, that's that. That's it for Django. No, that's not it for Django. Those of you who haven't gotten through day 4, try to get this done. If you finish, you can start looking at the deploy to Heroku stuff, and then we will tomorrow we will start talking about some of the new concepts and applied concepts that you'll be using for your project week next week for Lambda Mud. But other than that, thanks a lot, and I will see you tomorrow or today if you need help. All right, thanks everyone.